This question is about some period 3 elements and their oxides. So let's just remind ourselves that period 3 is the period that goes from Na to Ar in the periodic table. And their oxides would be like sodium oxide and phosphorus oxide, sulfur dioxide, sulfur trioxide. So we're being asked to write for phosphorus, which we need to remember is P4. So P4 and oxygen, O2, so excess oxygen, is asking you really to remind yourself, and do you remember, the phosphorus oxide is P4O10. And so to balance that equation, you need 5 oxygens. How would you distinguish between sodium oxide in a test and phosphorus oxide? So the thing is, these are both solids. So the test actually relies on the fact that they react with water to make different solutions of different pHs. So our first thing would be to react them with water and then add universal indicator because they're going to give different pHs. So Na2O reacts to form NaOH, which is alkaline. So the indicator turns blue. P4O10 reacts with water to form phosphoric acid, H3PO4, which is acidic. So indicator turns red. Then it's asking us to state the silicon crystal structure of silicon dioxide and sulfur trioxide. So silicon dioxide is one of those ones you have to remember, the 4 macromolecules that we remember for A-level chemistry. Carbon as diamond or graphite, silicon and silicon dioxide. Sulfur trioxide is 2 nonmetals joined together in a simple molecular structure. So how do we describe why silicon dioxide has a higher melting point? So we've already given its structure, so we don't need to do that again. But we would say SiO2, because it's macromolecular, has many strong covalent bonds between the atoms. Lots of energy needed to break these. Seems to have knocked us out of the question slightly there. And then SO3 has weak van der Waals forces between the molecules much less energy needed to overcome these. So the next part of the question asks us to write an equation for the reaction of sulfur trioxide, SO3, with potassium hydroxide, KOH. So sulfur trioxide is going to act as an acid. So when sulfur trioxide acts as an acid, it forms the negative ion in the salt. The acid always produces the negative ion in the salt, and sulfur trioxide forms sulfate 6s, because the sulfur is in a +6 oxidation state. And so the formula for the salt would be potassium sulfate, which is K2SO4, and then we're going to have some water, and we just need to balance that. So the base always provides the positive ion of the salt, and the acid provides the negative ion. So we're going to put a 2 here, and that should balance that equation nicely. Now we've got to do magnesium oxide, that's going to be our base this time, with phosphoric acid, that's going to be our acid. Okay, so the base provides the positive ion, which is going to be Mg, 2 plus ions, and the salt negative ions come from the acid, which are going to be PO4. So we've got PO4 3 minus ions from phosphoric acid and Mg 2 plus ions from the base. So we would need 3 magnesium ions for 2 phosphate ions, and then we're going to need some water. And if we balance that equation, because we need 3 magnesium ions, we need 3 magnesium oxides. And because we've got 2 phosphate ions, we need 2 phosphoric acids. And then if we balance out the oxygens and the hydrogens, we need 3 waters. The last thing it asks us to do is draw the displayed formula of the undissociated acid formed when sulfur dioxide reacts with water. Well, when that happens, we get the acid H2SO3. In that acid, the sulfur, because it was +4 here, it's still +4 over here. +4 oxidation state has 4 covalent bonds, 3 oxygens there, so it's got 3 oxygens attached to it, but it's got 4 covalent bonds. One of them's a double bond. And then the undissociated acid means the hydrogens are still attached. They're attached to the oxygens. We've displayed it. We've drawn every atom and every bond.